Good morning, everyone. Today we will discuss about a experiment, lab experiment, that is a simple pendulum. The simple pendulum lab experiment. From this experiment, 3 or 4 questions will rises in the examination. A student has to attempt the one question which comes to the particular student. No need to attempt all the questions. Only one question has to be done by the student. So here, after completion of this experiment or this session, a student is able to fix the simple pendulum to the stand and adjust the length of the pendulum, finds the time for number of oscillations, finds the time period by calculating, and calculate the acceleration due to gravity, and he or she is able to plot a LT graph and LT square graph. So after completion of this session, you are able to do all these activities. So here, once go through the what are the terms and definitions comes across this experiment while you are performing experiment in the laboratory. So as the name says that the simple pendulum experiment. So what is the simple pendulum, and is there any type of simple pendulums are available, and what is ideal simple pendulum, seconds pendulum. So in the process of experiment, what happens, what terms involves, this has to be clear before performing the activity or before performing the experiment or using the equipments. So simple pendulum is a metal bob suspended by a light string from a rigid support is called as a simple pendulum. Simple pendulum is a metal bob is attached from a rigid support with a string is called as a simple pendulum. The radius of this simple pendulum is R, right? Radius of the bob is R. A metal bob is suspended from a rigid support. Rigid support is called as a simple pendulum. So next, ideal simple pendulum. If a point mass suspended by a massless, inextensible and torsionless thread is called as an ideal simple pendulum. In pendulum, a heavy mass is suspended from a rigid support with a lightweight string is called as a simple pendulum. The simple pendulum is, there is no condition to suspend a bob or a sphere like that. You can suspend any mass irrespective of size, shape and material made up of. You can suspend bob of a iron, you can suspend a bob of made up of a piece of a wood, you can suspend. So a small heavy mass is suspended from a rigid support with inextensible thread, light weighted thread is called as a simple pendulum. But ideal simple pendulum, a point mass is suspended by the massless, inextensible and torsionless thread is called as an ideal simple pendulum. This ideal is a concept only. There is no availability of ideal simple pendulum in the practical. We cannot construct an ideal simple pendulum. Next is a seconds pendulum. A pendulum whose time period is 2 seconds is called as seconds pendulum. So this seconds pendulum takes 2 second time for making one oscillation. It is a seconds pendulum. The length of the second pendulum is approximately 100 centimeter on the surface of the earth, or it is equals to 1 meter. So here what is the length of the pendulum? So simple pendulum is a metal sphere is suspended. So this is the center of the bob, this is the radius of the bob, right? So origin O, this is a center. For example, consider center is at A. So the distance from rigid support to center of the bob is called as a length of the pendulum. The length of the pendulum is taken as the distance between the point of suspension to the center of the bob is taken as the length of the pendulum. Next, it makes some oscillations. Here simple pendulum makes some oscillations. Here this is a simple pendulum. It is making oscillations here and there, right? You can see this. It makes oscillations. From mean position it is going extremely left and coming right and coming to mean position. This is called as a one oscillation. So this is a one oscillation. So time taken to complete one oscillation is called as a time period. How much time takes to complete one oscillation is called as time period. The time period is represented by T. The units for the time period is a T. Units for the time period is a second. So it makes oscillations. Simple pendulum makes oscillations. Simple pendulum makes oscillation. It moves from, this is the mean position, from mean position it goes left and also it goes towards right. So this is the maximum displacement it moves. This is the maximum displacement. This is called as a amplitude. The maximum displacement of a bob either side of an mean position is called as a amplitude. The maximum displacement of the bob from its mean position is called as a amplitude. Time period is a time taken for one oscillation is called as a time period. And by using this simple pendulum, you have to find out the gravitational acceleration or acceleration due to gravity at a place or at your place. So what is the acceleration due to gravity? Every body falls on the ground. When you throw up, the body comes down. So Each and every body is pulled by the some attractive force of the earth towards its center. So acceleration acquired by a body due to the attraction of the earth towards earth center is called as a acceleration due to gravity or gravitational acceleration. This is represented, gravitational acceleration is represented by small g. The units for gravitational acceleration is meter per second square. So now these are the words or terms involved in the simple pendulum experiment. Now entering into the experiment. So what is the aim of the experiment? So aim is determine the acceleration due to gravity at a place using simple pendulum. So you have to determine the acceleration due to gravity at your place, and length of the seconds pendulum from LT square graph. So these are the two aims we have. Now you have to see what are the apparatus required for this experiment. So apparatus are simple pendulum, stop clock, Vernier calipers, meter scale, retard stand, and split cork. These are the required apparatus to perform the simple pendulum experiment. So the aim is to find out the gravitational acceleration at this place. So now here what is the simple pendulum? You know the definition of simple pendulum. See in this figure, cork, split cork, from split cork we are attaching a bob with a thread. Vernier calipers we need. This is the setup of a simple pendulum. The simple pendulum consists of a heavy small metallic bob suspended by a light string from the retard strand. What is the theory here involved in the simple pendulum experiment? So here the theory is, first you have to take Vernier calipers, because we need this Vernier calipers also to find out the radius of the given bob. So the Vernier calipers principle is the difference in the magnitude of one main scale division and one Vernier scale division is called as a least count. So here number of Vernier scale divisions are equals to n minus 1 main scale divisions. N number of Vernier scale divisions are equals to n minus 1 main scale divisions. This value is called as a least count. The least count can be defined as, by using any device you are able to find out the minimum distance. Minimum value is called as a least count. Here we have the least count of this Vernier calipers is taken as least count of Vernier calipers is equals to 1 main scale division by n number. How many numbers are there within the main scale division? Here 1 millimeter by 10 divisions. So least count of this is 0.1 mm, that equals to 0.01 centimeter. This is the least count of the Vernier calipers. So gravitational acceleration. Second is you have to find out the gravitational acceleration of the given by using the simple pendulum. So what is the gravitational acceleration? So gravitational acceleration from the simple time period of a simple pendulum, t equals to 2 pi under root L by g, where t is the time period, 2 pi, L is the length of the pendulum, g is the gravitational acceleration. Squaring both sides, t square equals to 4 pi square L by g, square root gets cancelled. Now from this equation, g equals to t square comes left and g goes left and t square comes down. So g equals to 4 pi square under root of L by t square, under root of, here g equals to here g equals to 4 pi square L by t square, where g is the gravitational acceleration, L is the length of the pendulum, t is the time period. So from this formula you can find out the gravitational acceleration at your place. And so then you have to find a procedure. What procedure you have to follow? So here for this you have to observe this formula. To find out the length of the pendulum, you need the radius of the bob. Because the simple pendulum is length of the pendulum is from supporting point to midpoint of the bob is taken as a length. So you have to take the radius. And from total length you have to decrease the radius, then you get the L value. So for this you have to find out the radius of the bob. For that you have to use Vernier calipers. So by using Vernier calipers, so main scale divisions or main scale reading MSR plus Vernier scale reading into least count gives the reading. This is the formula to find out the one reading. Here main scale, by using Vernier calipers you are going to find out the diameter of the bob. For example, this is first reading is 1.2 and Vernier divisions are 8. If you take this as 0.8 is the Vernier division, then 2.0 is the total reading. So this way you can find the values, right? So this is the way of as we discussed, everyone is aware about the Vernier calipers experiment. You have to take the main scale reading and you have to see the number of coincidence with Vernier division and Vernier scale reading. So Vernier scale reading is Vernier scale reading into least count. So now the total value of this MSR plus the total value MSR plus VSR into LC gives the value, right? You have to tabulate the readings. You have to take 3 or 4 readings as per given in the instructions. So now you get the radius. From diameter you have to take a total. From diameter you have to take you will get main scale reading, for example main scale reading, Vernier scale reading. So Vernier scale reading into least count. This is take A and this one is B, then A plus B gives the value, right? So now you are taking some values here you are getting. So take the total it and take the average value. That average gives the diameter. You will get a average diameter you will get average diameter of the bob, some x. So radius equals to diameter, average diameter by 2. So x by 2 you will get the radius. So now you know the radius of the bob, then you can find out easily the length. So you know you are measuring this value, for example this is taken A, this value, and you know the radius value, then A minus L equals to A minus R. This gives the length of the bob. So for this you have to do the experiment. So now you know the R value. So now you perform the experiment for the L by T square value. First arrange the bob. Suspend the bob with a distance from a point of suspension. For example, from the point of suspension to the bob length is 40 centimeter. Then pull it. The bob is pulled and release it. It makes oscillations. Bob is pulled and released, then it makes oscillations. Now here this is the mean position. You are pulling toward this direction and release it, then it goes left and comes right, left, right, left, right. It makes oscillations. A stop clock is placed near to the stand and you have to take a reference point from this side or this side. If you take from left, once goes right and comes left, one oscillation. If you take left, right, then it goes left and comes right. This is one oscillation. This is easy to take readings. If you take midpoint or the mean position as a reference point, it is difficult to note because it should go left and should go right, then comes to mean position, then it is one oscillation. So better to take reference point from any side. So now when the bob reaches your reference point, you have to take switch on the clock watch. Clock watch is started when the bob crosses the mean position or your reference point. It is counted as 0. When the bob crosses the mean position, your reference point, and stop clock So now you count as 1, 2, so on up to 20 oscillations. You have to count 20 oscillations. Now you have to count for the 20 oscillations. Fix the length of the bob, length of the pendulum, and take a reference point. Then switch on the clock, start the clock, then count the 20 oscillations. When the 20 oscillations completed, stop the clock and note down the time taken for the 20 oscillations. Then repeat it and make note the time taken for the 20 oscillations for that particular length. Don't change the length, don't touch the bob. Without touching the bob, you have to take note number of time taken for the 20 oscillations for second time. Now you change the length of the pendulum. Change the length of the pendulum, then repeat the same experiment for 20 oscillations and note down the time taken for the 20 oscillations. Like this, you repeat this experiment by changing the length of the pendulum. For example, 40 centimeter, 50 centimeter, 60 centimeter, 70, 80, 90, 100 centimeter, at 110, 120, like that. You can change the length and you have to note down the time taken for the 20 oscillations. Trial 1 and trial 2, 2 times you have to take. Now take the average time. So by noting the time period for different lengths 2 times, the usage of experiment apparatus is over. Now you have to calculate. You have to do the calculations. For this, here you are getting, for example, for 20 centimeter, for 40 centimeter length, the 26 and 26, 2 times 26, 26. Now the average is 26. This 26 seconds is the time taken for the 20 oscillations. So now you have to determine the time period for the length of 40 centimeter. For the length of 40 centimeter, the time taken for the 20 oscillations, say small t, is 26 seconds. Now you have to calculate the time period. Time period equals to small t by 20. So 26 by 20, you will get the sum value, right? So 1 point something. Now you have to square this t square. You need the L by t square value, that's why you have to square this value. By squaring this value, you will get the t square value. You will get the t square value. You know the L values. Now from this L, for example, L is 50. So you will get some t square value. Now you have to find out the L by t square value. So you will get, for example, 24.78 something. So this is your L by t square value, for example, I am saying. Now you have to take average. Now you have to take the average value. Take total. Take total value. And you will get L by t square values from table. So now you take 1, 2, 3, so on. You take total value. add it, and from this take average of that total by number of terms. So you will get average L by T square value. You will get average L by T square value. Now you know how the values of a L by T square value, then substitute this L by T square value in the formula. So what is the formula here? G equals to 4 pi square L by T square is the formula. So by substituting this value, you will get a G value. For example, 9.89 meter per second square. For example, I am saying this. So this is the way to calculate the G value. So from this formula, as you know everything, all the values, so substituting this L by T square, you will get G value, centimeter per second square, or you can convert it into meter per second square. This is the acceleration due to gravity you are getting from this experiment. Now by taking this L and T values, here we have L values, length, and T square values, and the L values and T values we have. So by using these values, you have to plot a graph. So L by T square and LT graph, both graphs we have. So L by T square graph is a graph drawn between the length of the pendulum and T square, the time square values. The L can be taken on the x-axis and T square can be taken on the y-axis. So the graph will be a L by T square graph will be a straight line which passes through the origin O. From this, the T square value is 4, corresponding is length is 100 centimeter. So T square value, whose T square value is 2 seconds, T value is 2 seconds. So T square equals to 4, therefore T equals to 2 seconds. So it is a seconds pendulum whose time period is 2 seconds is called as seconds pendulum. The value of length of the second pendulum is 100 centimeter, or that equals to 1 meter. This is a graph. From this you can find out, from using this LT square graph, you can find out the length of the seconds pendulum. So seconds pendulum time square T square value is 4, make down, and corresponding length is taken as the length of the seconds pendulum. So this is the length of the seconds pendulum. Here T square equals to 4. By using this graph, you can find out the seconds pendulum length, and also you can find out the G value from this graph. Here see for example, this is a T square value and this is a L value. Now you know the L by T square value. What is the L value here? L value is 100, T square value is 4, that's why 25 is a L by T square value. Now substitute this value, G equals to 4 pi root L by T square. So 4 pi square into 25. So you will get 9.8. So this is the value. In this way you can find out the G value by using LT square graph. The question also rises on this one. You have to find out the G value by using LT square graph. If asked questions, then you have to plot the graph. In this case, you no need to do the L by T square values in the tabular form. So just you take the L values and T square values, then plot a graph, and from the graph you have to take the L and T square values, then substitute the L T square values in the formula, then you will get a G value. And next graph is LT square graph, LT graph. So the graph between the length of the pendulum and time period. So length is taken on the x-axis and time period is value of t is taken on the y-axis. The graph is a parabola, passes through the origin O. This is the second graph we have in this experiment. So next observations, what you observed while doing the experiment. So you have determined the diameter of the bob, and from that you can extract the radius and main scale divisions, number of Vernier divisions and least count you observed. These are the observations. And the precautions you should follow. The precautions must be taken. What are the precautions are there for the Vernier calipers experiment and the simple pendulum experiment? Because we are using the two devices here, the simple pendulum as well as Vernier calipers, for the determination of this diameter of the bob. So here the screw of the Vernier tightly without exerting undue pressure to avoid any damage to the bob. The pressure should be normal, need not to tight the screw of the Vernier. And make sure that zero errors of the Vernier calipers. If there is no error, no problem. If error is there, you have to make corrections. And keep the eye directly over the division marks to avoid an error due to the parallax. Note down each observation with correct significant figures and units. These are the precautions taken care while using the Vernier calipers. And when the simple pendulum is using, so amplitude should be very small. Amplitude should be very small. The oscillation of the bob should be in the same vertical plane. Oscillation should be same vertical plane. So this is a simple pendulum. So amplitude will be very less, theta will be less, and the oscillation should be in the same vertical plane. Oscillation should be in the same vertical plane. It should be in a single plane. And bob should not spin. Bob should not spin. It should not spin like this while during oscillations. And parallax error can be avoided. Parallax error is avoided while taking readings. So these are the precautions you have to take care while performing the experiment using Vernier calipers and a screw gauge. So finally, whatever the answer you got by the calculating all the values from the graph, you have to write it here in the result. So G equals to, for example, 9.89 meter per second square or 989 centimeter per second square. No need to write all the observations in the result column. Just you have to write only whatever the result asked, whatever the question asked in the examination, and what is your aim here. So while doing the performing experiment, there is a lot of other external factors influence your experiment. Some of the students pushes the table, or some of the students are moving here and there, and suddenly air blows or air flows, or the power is off and suddenly power comes, then fans move, rotates. This type of external errors cannot be avoided, but you can minimize these errors by taking average. That's why you have to take more number of readings when you are performing the experiment. So you can, by that you can minimize the errors. So by using this simple pendulum, you can also find out the error percentage of error in measuring z value at your place. This is not in our syllabus. So the questions rises on this simple pendulum experiment. 3 or 4 questions rises on this one. So one is, determine the gravitational acceleration or acceleration due to gravity at your place. That is the one question. And second question, determine the gravitational acceleration and plot LT square graph. And third question, determine the gravitational acceleration from LT square graph. And fourth question, determine the gravitational acceleration and plot LT graph. And fifth one, determine the gravitational acceleration and plot LT square graph and LT graph. And next one, determine the gravitational acceleration and find the second length of the second pendulum from LT square graph. For all the questions, you have to write aim, apparatus, theory, formula, procedure, draw the table and take note readings, and calculation and precautions. Then finally, if you are asked to plot a graph, you have to draw graph diagram. Then you have to plot a graph on a graph paper, and then you have to write a precautions and a result. So these are the topics, main points you have to cover in the experiment while performing experiment. For this simple pendulum experiment, you need to perform 2 experiments. 2 means the one you have to perform experiment with Vernier calipers, and another is the simple pendulum. To determine the radius, you have to perform the experiment with the Vernier calipers. While using Vernier calipers, you should take care of the instrument and bob, because the most of the times, if you are not following the correct precautions, you won't get a correct radius, because bob is a small in a diameter, so the radius is a very small comparatively. That's why make sure that you have to follow the precautions and take the readings without any parallax. Here, while noting readings for the Vernier calipers, so main scale reading, don't get confused with the main scale reading and Vernier reading. So main scale reading, you have to take main scale reading, you have to note down the Vernier coincidence, then Vernier coincidence into least count, you will get Vernier scale reading. So add all these, you will get a diameter. Here for the LT square, make sure that length of the pendulum is exactly fixed, correct, and then take 2 times. Don't touch the bob when you are completed one reading, and then don't touch the bob. You have to take trial 2 also, then only you will get a correct value. Otherwise you have to perform from initial point. So here, and finally you have to write the result only whatever the question asked for. So don't explain all the things when you are writing the result. So after that you have to plot graphs between line t and line t square. So this is the procedure, and the experiment you have to perform in the examination or in your laboratory. Hope it is clear that you can perform experiment to find the accurate value, nearby accurate, not exact, because instrumental and environmental errors cannot be eliminated from the experiments. So as we are doing experiment in our laboratory, you have to concentrate and you have to make sure that the reading should be noted exactly without any parallax or without any deviation. That gives a, and you have to do the calculation part with concentration, then only you will get a correct answer, right? Hope you got the experimental procedure and method of performing simple pendulum experiment.